Excellent. So I think we're going to start, and the late entrants can just catch up. I'll be talking for a few minutes anyway, so this will give everybody a chance to join in, who's a little bit late. I'm John Bootland. I'm the Chief Executive of the Passivhaus Trust. I'm delighted to welcome you all to this session. I'm just going to explain what the Passivhaus Educational campaign is. We call it FEBS, and why we're doing this. And then we're going to crack straight on into the detail. Except my slides on. There we go. Before I do, the Passivhaus Trust, to explain why we're doing this and what else we do as well at the same time. So the Passivhaus Trust, we have three roles. One is to look after the Passivhaus standard in the UK and to protect it. The second is to promote it to whoever we can. And then the third is to look at the particular application of Passivhaus in the UK and to help enable that to happen more effectively. And obviously that fits very closely into this event today, where see Passivhaus schools as being one of the key markets and the key audiences where there's particular benefit from adopting Passivhaus. And also to protect what the standard means, or to work out how it applies to schools particularly. There are some particular, as you know, as you'll be aware, there are some particular requirements for schools in terms of the internal environment, the learning environment, catering requirements and so on. So looking at what has to be done specifically for schools to make Passivhaus work for them in the UK. We're into phase 2 of the campaign. We did a whole series of events last year just to look at what's happening with schools and also with education buildings. And the feedback at the end of those, there's lots of people interested. We had several hundred people attending these events. And we decided to move on to the next more detailed stage as phase 2 and to look at how to get through the procurement phase. And what steps and what you can learn from other people, what steps need to be taken during the various stages of procurement. We've also got a phase 2B, which we're looking at the costs and benefits, and we're going to start to work on that after this series of seminars. The seminars that we've got are, there's a series of 7. The first one today is just looking at what the benefits steps, as I said, within the procurement process. So there's developing a brief. We're going to look both at new build and retrofit. That's over the next 2 weeks. We're then going to look at the perennial problem of setting a budget and getting the costings right. And finally, moving on to how to appoint and manage designers and the early stage design decisions. So we're focused very much at the client end and the decisions that the clients can make before the design teams get to work and design and construction teams get to work. So the things that you as client side can control. And then right at the end, we've got a client procurement workshop, which is an interactive workshop. This is really the chance to talk to at the end and ask all the difficult questions that have stored up that you haven't managed to ask during the earlier tutorials. If you are interested in this, I think we've sent out an email to everybody, and please do let us know if you'd like to book onto that. It is only for clients. If you've got any questions that you think you don't want to admit in front of designers and contractors, it's fine. You can bring those to us there at the client procurement workshop, and it will be exclusive for that. And I should just say, for the whole series, we do have a series of sponsors for the series of workshops. That's Robertson's Construction, the East Central Hub in Scotland, and Archetype, the architects. We're very grateful for their support they provided, both actually helping pull together the events and also in helping to make this free for clients. So by their sponsorship, that's how we've been able to make it free to all the clients who are involved today. The still, next slide. Not working, it's very slow. Why can't I get it to work? Okay, we're going to just have to stop my share then, and I'm going to move straight on to describing what's happening today. So today's session is going to involve 2 speakers. All the sessions are going to involve 2 speakers. We're going to have 20 minutes from each speaker and then 10 minutes questions and answers. Today we've got John Palmer, who is the Research and Policy Director of the Passivhaus Trust, and Christopher, who is an architect from Architects. The reason we're going to do 20 minutes each is that we're going to have to record the session today, and then we're going to make the presentations available afterwards. We will record your Q&A. We won't make any questions available. We will just make the presentations available. So feel free to ask what you want, and it won't that won't go out any wider than this session today. If you have any questions, please, for the speakers, please put them in the Q&A, and then I'll pull them out and try and ask them to the speakers in each time. And if you've got any questions about how it's working, or if you can't hear anything or you can't see anything, then please put that into the chat, and one of the team will be looking after that to try and help you. Right at the end, so that will take us an hour, and then right at the end we've got a further 15 minutes left. So if there are lots of questions, we've got the option to extend for a further 15 minutes if we need. But if we don't need it, we'll just stop at 4 o'clock. If we need the time, we can run on to 4:15. Great. And then it's the same time every week. So next week will also be at 3 o'clock for the next session. So I'm going to hand over now, stop talking, and hand over to John Palmer to talk to us about Passivhaus's route to net zero for schools. John.
Great. Thank you, John. Hopefully everybody can see my screen. Welcome everybody. John Palmer from the Passivhaus Trust, and I'm going to do a little bit of scene setting today, and to hopefully convince you, if you're not already convinced, that Passivhaus is a good choice for educational buildings. And I've really got a very simple agenda, which is first of all to talk about Passivhaus as a route to net zero. And then to talk about what else Passivhaus might deliver beyond sort of energy and carbon, and look at some other benefits. So net zero. So we all know we need to get to net zero. How might we do that? There's obviously a lot of discussion about this. But this is just a little illustration of if we wanted to get our individual building or individual school to net zero. How easy is that? The dark blue is a CIBSE benchmark school, and the pale green there is a Passivhaus compliant school. CIBSE benchmark is measured actual data from what's out there at the moment. And then the scale on the left hand side here is how much of your roof area you would need to cover in solar panels in order to make this particular building net zero. And you can see that we're absolutely on 100% with a benchmark school if we have a single story building. As soon as we go to 2-story, there's less roof space, we can't manage it. And 3-story, we certainly can't. Where there is Passivhaus, we can make that net zero with every single configuration up to 3-story. But actually, that's not necessarily going to always be the case, because not 100% of the roof is available. It may only be 40%, 50%, depending on our roof configuration and which direction is it facing and is it optimal for solar generation. So actually, even with Passivhaus, it's going to be relatively difficult to get an individual building to net zero. And actually, for those of you who know a little bit more about Passivhaus, building single-story buildings isn't what we want to be doing, because they're very inefficient shapes. Very inefficient form factors. Actually, we want to be in multiple stories to make it more efficient and actually make Passivhaus easier and cheaper to achieve. So perhaps net zero individual buildings isn't what we want to achieve. And what we really should be looking at is a net zero UK, maybe a net zero region and net zero cities, but actually what we want is a net zero UK. And to achieve that, what we need to do is balance our demand against our generation capacity. How much are we going to use versus how much renewable energy can we generate? So how do we sort of work out what the big numbers are for that? Well, This is a Sankey chart showing the energy flows throughout the whole of the UK. Don't worry about too much about the individual detail, but we're coming from a left-hand side sort of source materials all the way over to delivery on the right-hand side. And if you add up the right-hand side, we are using, or in 2019, we used 1,740 terawatt hours of energy. A lot of energy, as you might expect. So how is this going to change, and how is this going to look in the future? Well, the first thing is that we're using lots of gas and a bit of petroleum, or quite a lot of petroleum there for transport. In the future, we won't have that luxury. And in the future, things will look a little bit more like this, where we've got mostly renewable sources on the left-hand side. So all that fossil fuel, pretty much with the exception of a little bit of gas, has all disappeared. And we're delivering it predominantly via electricity to the right-hand side. This is one of the future energy scenarios from the National Grid's work, which is net zero compliant. But what the really interesting thing is here, that 1740 has gone down to 765. And that's because we haven't got infinite amounts of renewable energy in the future. We've got a lot, and we'll have more than we have now, but it all costs money to deploy and to make the grid compliant to be able to move that amount of energy around. And actually, therefore, we haven't got infinite amounts of it, and we can only manage, in this scenario, 765 versus our 1740. That is about a 53% reduction in consumption. So I'm not talking about carbon here. I'm saying to make net zero actually possible, our energy demand as a nation needs to drop by 53%. And actually, in certain sectors, that's not going to be very easy to achieve. In fact, that's not going to be possible. So transport in particular, very difficult to actually reduce the amount of energy we need. Buildings, we can do better. And actually, therefore, we need to take our share of the load and then some. And this is being reflected in what we're seeing now emerging as standards for buildings in general, and particularly for schools. So these are some, on the right and 4 blocks there, some standards that are emerging or have emerged for schools. The DfE, Department of Education specifications, Scottish Future Trusts, LETI, and the Welsh Government. And you can see from where we are at the moment with our current kind of school benchmarks, that it's a little bit more than that 53% reduction, which is kind of what we're going to need to make everything balance and get to net zero. So what might help us get to those kind of specification levels? Well, you probably already know that I'm going to tell you that it's Passivhaus. So standards, targets on the left, targets are great. If you can't achieve them, then they're not really much use. On the right, we've got the CIBSE, actual performance, the CIBSE benchmark, and then 3 Passivhaus schools. And you can see that they are achieving that the benchmarks pretty much, and they're also below that 53% reduction that we need to get to net zero. So my kind of takeaway from this is that net zero is not easy. It's not easy across the board in all sectors, but buildings, we can do a lot. And what you'll notice from this chart, and you probably have picked up at it from your knowledge of Passivhaus, is that it's the heating demand that is where we are using most of our energy right now. And that's what Passivhaus, with its fabric first approach, is going to target predominantly. And so that's what we can get down. We can get it down to levels which are commensurate with net zero. If we don't do that, if we still have a significantly high heating demand, then quite frankly, on current projections, there will not be enough renewable energy to go around in 2050 to get us to net zero. So moving on to the next point, really, what does Passivhaus deliver? Well, many people think of Passivhaus as an energy standard, and indeed it does do very well on energy, as we've just seen, and that in turn will drive fewer carbon emissions, low carbon. But Passivhaus is very much a comfort-led standard, but it also delivers several other areas. And we've been looking at, John mentioned earlier, we're looking at the broader benefits of Passivhaus. We've been starting to tease these out and to quantify them and to put them down. And what we've come up with is this kind of categorization. So building performance right in the middle, absolutely, that's what Passivhaus delivers primarily, is a building that performs. But As a consequence, and the co-benefits of that is that it delivers on what we need to achieve for climate emergency, which I've just spoken about. It actually also delivers on health and well-being and people performance, and I'll explain a little bit more about that in a moment. It also has some quite significant financial benefits and financial levers, and finally some social benefits as well. So all that breaks down to look like this. So we've got our building performance, our climate emergency, financial benefits, people performance, health and well-being, and finally some social. Now, you'd be pleased to know that I'm not going to go through all of these today, and some of them aren't necessarily benefits that we would want to major on in educational buildings. Cold homes and things like that are particular to the domestic sector, but there are a few things that I really want to pick out. The ones in green in the climate emergency I've already touched on, and that's kind of almost as read. It's going to help us with net zero, tick. But there's some other things that these passive house buildings are going to do for us. They're going to help with comfort levels. Why is that important? Well, people, as we're going to see in a moment, perform better. It's going to help with some productivity and potentially some learning outcomes. And it's going to help with our health outcomes in our, what in most cases are working environments. So if I can just kind of summarize the things that contribute in great part to that, we're looking at improved indoor air quality in a passive house building, and we're also looking at improved excellent levels of thermal comfort, and we're also looking at excellent disconnection from outside noise and quiet noise levels. And when I talk about indoor air quality, I'm talking about a variety of things there. It could be CO2, it could be particulates, it could be volatile organic compounds. And I'll explain more about those in a moment. So what does passive house achieve in these areas? So let's have a look first of all at thermal comfort. Now, I'm not going to spend too long on these slides because Chris is going to present something very similar to this and come at it from a slightly different angle in terms of overall performance. But what I want you to take away from this is that this is a winter condition, and you can see the black line is a 1970s conventional, and then the kind of greenish line above that is a next generation 2009 school, and the dark blue line is a passive house compliant school. So you can see that in winter, our less well-performing schools are down by 16, 17 degrees overnight. This is a 5-day period, and just meeting 21 in some cases, and actually later in the week, not even getting to that. Whereas our passive house building is hovering between 20 and 23 constantly throughout the week, even overnight. So optimal thermal conditions in winter. And then if we look in summer, similarly, our black line and our green line is way up there, 26, heading towards 27 at the beginning part of this week. Our passive house school is sitting there between 20 and 23 constantly throughout the week. So thermal performance, winter and summer. Why is that important? Does that make a difference? Well, yes, it does. And there is now quite a lot of evidence to suggest that both thermal comfort and our auditory comfort as well, so noise levels, have quite a big impact on people's performance. Both too high and too low means we're going to impact people's learning ability and also their cognitive performance. That's quite significant. Next, indoor air quality. So this is a chart showing CO2 levels in those 3 categories again. We've got the 1970 school, in this time in pink, purple for the building regulations, more modern, and then finally the passive house school. And what you can see here is that our CO2 concentration in the 1970s is peaking at anywhere up to 5,000 parts per million in December, but really hovering anywhere between an absolute minimum in the summer when we can open the windows, and people tend to open the windows of kind of 500, but most of the time being well above 1,500 parts per million. A little bit better performance from the building reg school. Passive house, always below, even peaking below the 1,500 parts per million, and generally, in most cases, below 1,000. Now, why is CO2 important? It's important in itself, and we'll have a look at in a moment about the effects of CO2, but it's also important because it's a good indicator for other pollutants. So it's a good indicator for VOCs, levels of VOCs, and levels of particulates as well. So why is that important? Well, again, there's now evidence that CO2 levels and better ventilation rates is going to have an impact on the people in our educational buildings. I'll just let you read those 3 quotes. So again, quite significant. And that's just sickness and attendance. What about learning ability? So you can see that there is a very clear link now in a number of studies between levels of CO2s and VOCs and cognitive performance. So we really should be giving our people who use our schools the best chance of learning when they're there. Another piece of evidence is this, which shows you the impact on decision making at various concentrations of CO2. So you can see the black dots there at 2,500, the bluish ones at 1,000, and then the pale ones at 600 parts per million. And you can see that by the time we get into 2,500 parts per million, people's decision making is becoming dysfunctional. And what about pollution? Well, there is now some evidence that pollution has a disproportionate effect, disproportionate impact on children for a variety of reasons, and they're on the screen here. And how does Passivhaus perform in terms of pollution? We know that it will provide good ventilation, but we also know that Passivhaus schools, because they're airtight and because everything comes in from an MVHR system, a mechanical ventilation heat recovery system, with a filter, then we are much better able to control the pollutants that are coming into the building as well. And this just illustrates what the sort of level of pollutants we've got. This is an MVHR filter before the top one, obviously, and then just 3 months after being in situ, filtering out all those in the main particulates before they get into the building. And Passivhaus achieves lower levels of particulates and therefore will reduce some of those effects that we saw earlier. So that was a very quick run through some of the key benefits of Passivhaus that relate to educational buildings. There are others, and I'm happy to discuss those in the Q&A or a bit later on. But really, my summary is that why should you choose Passivhaus? Well, the first thing is that it gives us our best chance of getting to net zero. It gives us our best chance of getting energy demand down to a level which is commensurate with what the nation needs to achieve for net zero. And the second is it does so much more, and it's of great benefit to the people who are going to be using our schools, and we owe them that to give them the best possible learning environment. So thank you very much. That's me done, and I will now hand back to John.
Great, thank you very much, John. If there are any questions, if people would like to put them in Q&A or raise your hand, then that would be excellent. John, just a quick thought, a quick question if you don't mind. So many of the quotes or information you provided were not just from schools, but from other buildings as well.
Yeah.
Could you tell us, do we have much information from schools specifically? And how much evidence do we have on that?
So some of the evidence that I put up was specifically relating to schools, but there is, there isn't a huge amount of conclusive evidence relating to Passivhaus schools because we haven't got that many Passivhaus schools. And I know Chris is going to talk a little bit more about performance of Passivhaus schools. So what we're doing, sorry, turn on my video. There we go. What we are doing in terms of trying to quantify the benefits is to really draw the link to say, right, so there is a lot of evidence, for example, that high levels of CO2 affect cognitive ability, and that's quite clear, and I put up a range of references showing that, and a number of those are in schools. And then what we can also then show is we can show that Passive House delivers very good levels of indoor air quality with very low levels of CO2, which is what I demonstrated as well. So there's a sort of a two-step link there. Rather than absolutely demonstrating that Passive House schools deliver greater cognitive performance, what we demonstrated is that greater cognitive performance is delivered with lower CO2 levels, and Passive House schools are known to deliver lower CO2 levels. So it's that kind of double link is what we're demonstrating.
Great, thank you. And if you stay on for a minute, John, on video. Abigail's asked a question about whether we're going to cover universities as well in this series of events. So we're not specifically looking at university case studies. We think all of the lessons that apply to schools will also apply to universities. We have got plans to run additional procurement workshops just on university buildings at a later date, look specifically at some of the details there. Some of them have different requirements, so student accommodation or STEM labs or similar. So we'll look at those particular things at a later date. But the kind of generic points that we're making in this series would apply equally to universities as well. And then John, looking at a question from Pete. What in particular sets Passive House apart from other buildings to do with summertime thermal comfort? Is it openable windows and vents, or why? Why does Passive House work so well?
Right, okay, my favorite topic, summer overheating. So the first thing is that Passive House has a summer overheating criterion, which is the amount of time that the building can spend above 25 degrees over the course of the year. And that's limited to technically 10% for the certification criteria, but actually we design to 5% in the UK as best practice. And that actually is coming down to a little bit lower as well in the future. I'll touch on that in a moment. So the first thing, is that there is an overheating criterion which has to be adhered to. And then the second point is, does a Passive House building, is it more likely to overheat than a non-Passive House building? Well, actually, and because people have got this image that you've made everything nice and insulated and airtight, so therefore it's got to be worse, hasn't it? It's got to be more at risk. Well, the first point is that when you are hitting that criterion for overheating, what you are doing in order to achieve that is making sure you've got two big things right. And the two big things which tend to cause overheating is one is solar gain and the other is internal gains. So those are the first two things. So we need to control those gains. So if you have optimized those correctly, then we'll have a good daylighting, but not a excess amount of solar gain. And we'll also have dealt with internal gains in terms of efficient domestic hot water systems and efficient other systems which might produce heat. But we've also modeled them correctly so we know what the risk might be. So if you dealt with, we've minimized those two. And then the other half of the equation is to maximize our cooling potential. And we've got two primary, without air conditioning, we've got two primary mechanisms of cooling, and that is to move cooler air through the building. Cooler air tends to be at night or even during parts of the day, even in the summer. So moving that to the building either through windows or secure openings or via our mechanical ventilation system. Our mechanical ventilation system will go into bypass mode when it realizes that we've got cooler air outside and the building is heating up inside, and we'll be bringing that cool air through. So that works for us. And the other thing is that in the design, we'll have made sure those opening areas, as Peter said in the question there, will be sufficient to maintain that cooling. So that's the key point. The actual amount of insulation, the air tightness is not relevant, other than extra insulation is actually going to keep the building a little bit cooler once we maintain that temperature inside. So, but it's solar gains and internal gains, which are the big hitters, which we need to control. So we're just about to publish some additional guidance on that for UK designs, which is going to take us a little bit further in terms of stress testing these buildings for the future, making sure that they're robust when we get climate change coming and hitting us, higher summer temperatures, a lot more sunshine, but also robust in the face of maybe we've got more students than we thought and there's extra internal gains, or there's an issue with the shading, we've got more solar gains. So that will go on, layer on top of the existing criterion and make sure that we're designing buildings in the, passive house buildings which are robust for the future in the UK.
Great. Thank you, John. So quite a complicated answer. And we've been doing a lot of work on overheating recently, and we've just introduced this stress test that John's mentioned. At a very simple level, we calculate what all the heat gains are for a passive house, and we work out how to deal with them in advance. So John's explained how that works, but at the very simplest level, that's why the passive house will perform better in the summertime than the other school buildings. I don't know if many other people have got experience of overheating in a school, but it has proved to be quite common in recent years until we've moved on to the passive house designs. So we think that it's quite a common problem that people are likely to encounter. And John, I was quite surprised as well about the levels of CO2 that you can get into in existing schools. I mean, 5,000 parts per million sounds like a lot, and 1,500 is a number I know that most buildings are working to, or 1,000, 1,500 is a maximum. Are there guidelines against 5,000? I mean, is that with the BB standards, for example, for the DFE?
Yeah, so the BB standards are, I think 1,500 or 1,000 best practice. I think they do it in a slightly different way in terms of ventilation rates, but they're designed to achieve around that kind of level, below 1,500, below 1,000. So yeah, getting up to 5,000 is obviously not compliant with any standard. So A, it doesn't comply with the standard, but B, as we saw, it is also affecting the the cognitive ability of people in that building. But it's not, it's for that era of school, it's not untypical. And I certainly remember when I was at school, Friday afternoon, hot sunshine coming in through the window, but it's building up, CO2 is building up, it feels stuffy. What concentrations was it then? It's quite possible that we're up to 5,000, and we as humans are very we're very sensitive to heat and cold, but we're not very sensitive to air quality. So all we perceive is that it becomes a bit stuffy and we get a bit tired, but actually we haven't got a good mechanism ourselves of detecting the levels of CO2.
Right. I'm going to abuse my position. So my partner works in a school, and during the COVID times, she was asked to keep all the windows open, and yet the heating was put on to a certain amount. She was wearing coats and gloves and hats in the classroom, and yet didn't feel at all secure. Could you just expand a little on the benefits of passive house ventilation for COVID or for that kind of situation?
Yeah, so obviously it's a emerging field, but the general consensus seems to be that the higher the ventilation rate, the more the less likelihood there is of indoor transmission of COVID, which kind of makes sense because we're moving any aerosol droplets outside as quickly as possible. The problem is that in a conventional building, that you by first of all, as you say, opening the windows is the way that you're going to achieve high levels of ventilation, and that's not great in winter. But even where we've got conventional mechanical ventilation, we are extracting and bringing in, and we're going to end up with a significant amount of heat loss, cold air coming in. So it's not great from an energy point of view. So with passive house build, or not just passive house, but any building which has got MVHR, what we're then doing is we can raise the ventilation rate to a certain extent, and that will slightly increase our losses because we're recovering all our heat from the outgoing air, and we don't have a huge energy penalty. And the other good, great feature of MVHR is that we're not mixing our incoming and outgoing air streams. So all the air that's being extracted from the building is going outside. It's also going through a filter before it actually gets outside. All the air that's coming into the building is coming in through a filter, and then whilst the heat from the outgoing air is being used to heat it up, there's no mixing of the airstream, so you get completely isolated.
Great, thank you. My partner was absolutely convinced of the need for Passivhaus schools during this last quarter, particularly around about January time when it was freezing cold. She was certain that that was the way forward. And just to note, we've had a comment that the CIPSE guidelines are 800 parts per million for there's a maximum for designing CO2 levels within buildings. And I think as Don showed that the Passivhaus schools achieve those levels, or certainly below 1,000 as their norm. In nearly all circumstances. So we put forward Passivhaus as being a very good solution for low energy net zero schools. Thank you very much, John. That was really enlightening and great information as well. So I'd ask us to move on now. If Krista wouldn't mind turning on her video and her microphone, that'd be great. So Krista is an architect at Archetype. She's worked on the design of schools, but also particularly has been working on the POE, so the monitoring of the performance of schools through several iterations of design that have been developed at Archetype. Some amazing data and some amazing figures, and actually using them as part of her PhD at UCL, which is in the process of being written up. I don't know how long that will take, but Krista, we're delighted that you've come to share this information with us. Thank you very much. And I'm going to hand straight over to you now. Thank you.
Thank you, John. Could we have the slides, please? Thank you, Laura. Thanks for the opportunity to talk about benefits of Passivhaus for schools in this webinar. So, on the next slide, please. Thank you. I will briefly go through for this presentation. I will go through our experience at Archetype with Passivhaus schools and our involvement in relevant research. I will then talk about challenges of environmental design in schools, the importance of getting indoor environmental conditions right, and then we'll go through some key benefits of Passivhaus for schools, illustrated with evidence from post-occupancy evaluation monitoring. And finally, I will mention further considerations for the design, delivery, and operation of Passivhaus schools, focusing for this presentation on the importance of empowering the user and some ways that we use to achieve this. On the next slide, we have listed here some primary and secondary schools designed and delivered using Passivhaus methodology by Archetype. This is a considerable experience with the delivery of Passivhaus schools. Among the schools is the first certified Passivhaus primary school, Oak Meadow, completed in 2011, and Harris Academy Salon Secondary School, completed in 2019, which is the first secondary school to be certified in the UK and also the largest Passivhaus school in the UK. In the next slide, school design at Archetype has evolved through a series of POE studies and research projects with academic partners, which aimed at providing evidence of performance and at improving school building design. Early POE studies looked at pre-Passivhaus schools designed by Archetype. A KDP study with Oxford Brookes looked at St. Luke's and the Willows primary schools. Then a technology strategy board study looked at Staunton-on-Wine and Bessemer Grange. And then in 2011, the first Passivhaus schools were built by Archetype, and subsequent studies continued to take our design forward in the last decade, including or focusing exclusively on Passivhaus schools as case studies. And in the next slide, I'm looking at I wanted to give some information about two research projects, the KEEN and the CHA project, which were a collaboration between Archetype and academic partners and focused or included Passivhaus primary schools. The earlier KEEN study took place between 2014 and 2016, and it was a comparative study, which included the conventional school, 1970s conventional school, which we thought represented a large portion of the existing school building stock in the UK, 2 pre-Passivhaus schools by archetype, and 3 Passivhaus primary schools by archetype, including the first one. The main research question was how do Passivhaus schools perform compared to pre-Passivhaus and conventional schools? The second study is the ongoing one, which is also my PhD project, and it started in 2016. We're currently publishing and are in the process of publishing and writing up findings. It is an in-depth study, and the main research question is how do design and operational factors influence the indoor environmental performance of Passivhaus schools? Both studies included monitoring of indoor environmental parameters and energy use, as well as user surveys, but followed different methodologies. And both studies were developed in recognition of the importance of indoor environmental quality, as well as of energy performance of school buildings. In the next slide, well, the purpose of this text-heavy slide is to stress the importance of the classroom environment and the fact that there is a lot of evidence in existing literature to show how different aspects of the indoor environment can have a measurable impact on health and learning in children. John did mention a few of these. I have additional, I have some of the references that we've taken this information from here. So we know that indoor air pollution has adverse effects on respiratory health and academic performance and attendance. Inadequate ventilation in classroom has been linked to reduced academic performance. High CO2 levels, CO2 is generated by the occupants, and high CO2 levels in the classrooms are linked with reduced cognitive performance and attendance records. Dampness and microbiological factors with asthma and respiratory infections. Increased fine particulate matter. Fine particulate matter is a fine dust, and in schools this comes mainly from outdoors, from traffic-related sources. Is linked with adverse health effects, including cough, eczema, dermatitis, headache, and nausea. At the same time, asthma prevalence in school children increased with exposure to PM2.5 levels over 17.5 micrograms per cubic meter, which is somewhere between the long-term and short-term limits set out by World Health Organization for exposure to this pollutant. Increased temperatures in summer were associated with lower self-assessed performance. These are only some examples of available evidence showing that ventilation, indoor air quality, and thermal comfort in schools matter. Next slide, please. The current guidance for ventilation, thermal comfort, and indoor air quality in schools is informed by existing literature and existing evidence. And in 2018, this guidance superseded the 2006 version, introducing more stringent requirements for ventilation and CO2 levels, which we now see is perhaps temporarily even more stringent. It also introduced more considerations for indoor air quality. However, many studies, including the one I'm referencing here, Corsavi et al., fail to provide sufficient ventilation and therefore a healthy environment suitable for learning. Next slide, please. As part of our consultancy services at Archetype, we undertake evaluation of performance of occupied buildings, in the design and the delivery of which we're not involved. So many schools we study fail to meet the Building Bulletin 101 requirements. And this is an example here. In this graph, we're looking at CO2 levels in classrooms of a new built high school in the UK. During a cold week in winter, windows were closed to maintain temperatures, and as a result, CO2 levels at an acceptable level in all 5 classrooms, not only acceptable, seems to be an issue with screen sharing.
I think we're just going to reshare. There we go.
Thank you so much. Next slide, please. Great, there we are. So this graph. So part of the difficulty the industry has in achieving good indoor environmental conditions in schools is illustrated in this diagram. As John mentioned, classrooms in the UK and especially in primary schools have a high occupancy density. Densely occupied classrooms have high summertime overheating risk, as well as higher indoor air pollution rates. As a result, higher ventilation rates are needed, but because window opening is not always an option because of outdoor air pollution, external noise, or weather, this will often lead to insufficient ventilation rates with important consequences for the indoor environment, with insufficient ventilation rates leading to higher CO2 levels, higher coarse dust, and volatile organic compounds, which are mainly indoor sourced, and of course, higher overheating risk in summer. If high ventilation rates, the required ventilation rates are achieved, then this can lead to higher heat losses in winter and thermal discomfort. These challenges are addressed with a series of solutions proposed in the Passivhaus standard, as already explained, with mechanical ventilation or mixed mode ventilation, preheated air with heat recovery, shaping a robust methodology for ventilation, combined with minimized heat loss through building fabric for thermal comfort and energy use. Next slide, please. The benefits of Passivhaus are already mentioned by John. So in the following slides, I will use the evidence from the two research studies that I mentioned to illustrate that these benefits what these benefits meant for specific schools included in our research, focusing on ventilation, thermal comfort, indoor air quality, and energy. This graph that we already briefly saw in John's presentation illustrates the benefits of Passivhaus for ventilation rates and CO2 levels in classrooms. It was produced from data we collected as part of the Keen monitoring project. Oh, thank you, yes. In Passivhaus, pre-Passivhaus, and a conventional school that we use as a baseline, the high CO2 spikes in the conventional school that we see here are typical in winter. The CO2 profiles are improved in the carefully designed pre-Passivhaus school by archetype, and further improved with window design and ventilation strategies in the between the first and second generation Passivhaus school. The blue line, as John mentioned, shows CO2 levels in the second generation Passivhaus school. These meet the current stringent requirements of the Building Bulletin 101 and are pre-COVID requirements, and are well below the 2006 requirements shown in this graph. In the next slide, this graph shows temperatures during the same week in winter in the same schools. As expected, increasing ventilation rates in the Passivhaus school did not compromise thermal comfort. On the contrary, thermal conditions are within the comfort range in the Passivhaus school and seem completely uncontrolled in the conventional building. The very low temperatures that we see just before the start of the day and the great fluctuation also increase the risk of mold growth in the conventional building. And the next slide, the second generation Passivhaus school, which was informed with lessons learned from our experience in previous schools, also shows better control of summertime overheating risk. The high spikes seen in the conventional school, I think we have to go back one slide, thank you. The high spikes seen in the conventional school, the gray line again, are not seen in the pre-Passivhaus and Passivhaus schools. The blue line of the second generation school shows that the ventilation strategies alongside improved calculations of internal heat gains, which influence solar control design, have led to a comfortably cool temperatures during a typical summer week. Indoor air quality, in the next slide, indoor air quality is greatly influenced by outdoor source pollution, as John already explained. But the more ventilation rates increase, the more exposed the indoor environment is to outdoor air pollution. This is of particular concern for schools in urban and suburban environments. This graph was produced with the data we collected during monitoring in 2018 and 2019 as part of our ongoing CHA study. I have added our conference paper for reference on the slide as well. The graph shows indoor and outdoor fine dust levels in classrooms from two Passivhaus schools in winter and in summer. The outdoor levels are shown in gray, and the indoor levels in blue for winter and yellow for summer. The schools were in suburban and urban environments, but not immediately adjacent to roads with heavy traffic. Nevertheless, outdoor particulate matter, outdoor PM2.5 levels were high and exceeded most of the time the long-term exposure limit set out by WHO. The short-term exposure limit was often exceeded in winter in School A outdoor location. And while outdoor levels were this high, indoor levels in all schools averaged and remained most of the time below 10 micrograms per cubic meter, which is the long-term exposure limit. And this shows a level of protection of the classroom from the outdoor PM2.5 by the building. This level of protection can also be illustrated in indoor to outdoor ratios. With indoor to outdoor ratios, the smaller the indoor to outdoor ratio, to outdoor concentration ratio is, the better, obviously. In the next slide, I've added another graph to show that indoor to outdoor concentration ratios are less than 1 in Passivhaus schools. I'm showing here, this is showing for School A. But were higher than unity in conventional non-Passivhaus schools. These are marked with the horizontal blue and yellow lines for winter and summer, the non-conventional schools. In other words, while indoor conditions were better than outdoor conditions in Passivhaus schools, this was not the case in a school sample consisting of various school buildings in London from the Symphony UK study. This included non-Passivhaus schools, clearly. The methodological differences between these studies mean that we have to be cautious when interpreting these findings and these differences, but we could argue that Passivhaus gives opportunities for cleaner indoor air by bringing air from higher levels and away from local pollution sources with the use of suitable filters with mechanical ventilation. In the next slide, as we've seen in John's presentation, the schools account for a large portion of carbon emissions, 15% of the public sectors, and the benefits of Passivhaus for energy are critical today. As the school building sector has an important role to play in the transition to a low carbon UK economy. This graph shows the annual energy consumption per square meter treated floor area of the pre-Passivhaus and Passivhaus schools included in the Keen project, in the Keen research, and illustrates the strikingly improved energy use for space heating in the second generation school in particular, when compared to the typical and good practice primary school buildings. The benchmarks included here represent the 50%, the median of the primary schools in England and in Wales from the DEC database, and the good practice, the 3 quartiles of the primary schools. An improvement can also be seen as we moved along the archetype schools timeline. Next slide, please. There are many more considerations for the design of a good Passivhaus school. Some are listed here. And as for my closing point in this presentation, I would like to focus on the considerations of empowering the user, for empowering the user. Our experience tells us that this can make a difference in terms of building performance and, of course, of user satisfaction. Next slide. Users need to be recognized as an important factor influencing the indoor environment and building performance. Therefore, users' behavior needs to be considered in the design and delivery. This is an extract from a user guide that we designed for Wilkinson Primary School. More detailed information, more technical information was provided for the facilities managers separately. In this extract, the users were given an explanation of how the ventilation strategy in the building works, the so-called cascade strategy, which works by directly supplying fresh air into the classrooms and extracting air from the centrally located hub space. And it also works when the hall is occupied in the next slide, when most pupils are in assembly at the hall. The classroom guides were also issued, including more detailed information about the classroom, lighting controls, and other useful information. In the next slide, control strategies can greatly influence indoor environment and energy use in schools. The level of user control of windows is one important aspect. Lessons learned from the first Passivhaus schools led us to reduce the use of automated operation of windows to the minimum and to keep only user-operated windows in classrooms. To help the users respond to CO2 levels in the classroom, however, as this is, as John said, this is not often noticed by users. Users are respond to temperatures more than indoor air quality changes. A traffic lighting system was introduced, informing users, but allowing them to maintain control. The levels of user control and automated control can vary greatly, of course, between different schools, and these need to be tailored to each specific project. Finally, and the last slide, soft landings is an important framework through which the user is included in the procurement process and the building in use becomes the focus. It may include monitoring of several parameters and user surveys and fine-tuning workshops. The design and delivery team, the client and the users continue their collaboration after the building is occupied to make sure the building is working as it is designed to, and in a way that works for the users also, therefore contributing to the elimination of the performance gap. My final slide, the next slide is the final one. Thank you very much for your attention.
Thank you very much, Krista. That was excellent, and great to see that there's actually such detailed research on schools themselves, so specific research that directly applies to this question. In the remaining minute or two, and we will carry on after 4 o'clock, but I'd like to get this question in before if we can, in case people have to go. So we've got a question about whether or not there is overheating data in hotter summer periods. So you gave a week in June. Do you find the same conditions can be achieved during July and August? And have they been tested in a heat wave? Do you have information from a heat wave, for example?
I'm afraid that from our monitoring, we weren't lucky enough to have a heat wave. This occurred in, this did occur in both our monitoring campaigns, but when the school was closed. We do believe that the ventilation rates that are achievable are able to, seem to be able to, or were designed as well in that way, to limit overheating risk to appropriate levels. But unfortunately, we don't have monitoring data of that yet. So we did ask the users to tell us in the user survey what it's like on a typical summer day, but also on a particularly hot summer day. And the feedback we received did not show any issues with overheating in summer. I think that obviously the Passivhaus methodology played a role, but fine-tuning the systems and listening to the users also helps make sure that ventilation settings are right and meet their requirements.
Yeah, it's interesting, isn't it? The hottest days will occur during July and August when most of the schools aren't full in any case, or aren't used to full capacity. I was particularly interested as well in the PM 2.5 levels, so the small particulate levels coming into the schools from external traffic. I mentioned that my partner works in a school. I didn't dare mention this at this point about particulates to her. So as they were opening all the windows to increase the ventilation rates, the amount of pollutants coming in it was quite significant, and I didn't want to get her to worry about that as well as the other parts. So very interesting to see the figures you pulled through. And Chris, have you gone on to next generations beyond this and done further monitoring of those as well? Not just on the particulates. Have you gone on to, you talked about first and second generation passivhouses going up to 2014, 2015. Have you gone on to monitor further iterations since?
Yes, in our more recent study, we have been monitoring, I guess it's one of the latest Passivhaus schools, so that would be a third generation or further down the line. We do see even lower energy performance data very good cooler summertime temperatures and lower CO2 levels. However, in such comparative studies, there are several limitations. We want to see how these schools operate under full capacity, as some of the more recent schools are not yet fully occupied. So a comparison would be fair a bit later in the next years.
Great. And we do have a question in the chat that I'm going to try and pick out, which is what were the key lessons from the early stage monitoring that led to improvements in the second and third generations? What were the key things you found? And one suggestion was it to do with control strategies or the end user guidance? Were they two things, or was it something else?
Both control strategies for ventilation and user training, not necessarily user training, but communication with the facilities management team. Because of the level of automation there, there were a few issues to be discussed with the facilities manager. So the facilities manager had to be aware of a lot of issues. Of course, they were, but from the user surveys and from our understanding of how the school operated, we believe that we did change some of our approach to several things. For example, like I mentioned, window design and control of the window design was given to the users, at least in the classrooms. Sometimes it's best to keep automated controls, but we try to limit these in hub spaces, high-level windows that can be forgotten by users. And another lesson learned would be in terms of internal heat gains. These were, I believe, later on revisited for the next school buildings. And window design, for example, the sill height was increased to match approximately the desk height in the classrooms, as it was decided that the lower part of the glazing pane only contributed only gave solar heat gains in the classroom that were unnecessary, while they did not improve daylight conditions in the classroom as much.
Great, so two very useful points. And the point about engaging with facilities managers, particularly in schools where they probably quite often don't have a professional facilities manager or a dedicated facilities manager who can specialise in this, is an important point. We might come on to that again later in the series of these tutorials. I think unless there are any other questions that people want to post in the Q&A, I'm going to call a halt to the session and just say a great thank you to Chrissa and to John. I'm just going to put up the slide to remind you of the forthcoming tutorials that are coming on every week. So we have a whole series starting next week at 3 o'clock on Wednesday, and we're going to look at the brief all the way through to the early stage design decisions and so on. And I'd just like to point you towards also the Passivhaus Trust education page or campaign page for education buildings. There are some videos up there already and some case studies and examples that you can go and have a look at. So please do take note of those. Yeah, and we look forward to seeing many of you next week at the same time for the next session. So thank you very much, John and Chrissa. Thank you very much to the team for hosting, and thank you all for attending and joining us today.